right, Algebra 2 students, welcome back. Today we are moving on to section 2.7. The first part of this section is all about linear quadratic systems. Linear quadratic systems is a system that's made up of two equations. One equation is linear, so if you graphed the equation you would get a line. And it's in that familiar formula, the y equals mx plus b, that you explored quite a bit back in Algebra 1. And then the second equation is a quadratic equation. And we've been looking at these quadratic equations in this chapter. So a quadratic, remember, the graph is a parabola, it makes that U shape. And then it's in the form of y equals ax squared. X squared makes it quadratic, plus bx plus c. So the first thing we're going to explore is how many different numbers of intersections. So what's all the possibilities of the way that a line and a parabola can intersect each other? So we're going to do a few sketches to show the three scenarios. So my first scenario would be if I had a quadratic, a parabola, and then the linear equation, the line, intersect this parabola twice. So in this case, there would be two intersections. One, two. The other case would be if you had a parabola and a line and it intersect just one time. So one intersection. And then my last scenario would be if I had that parabola and a linear and it intersect no time. So no intersections there. So 2, 1, or none. So that would be the answer to this problem. How many possibilities or how many different numbers of intersections are possible between a quadratic and a linear? Well, we just figured out there are 2, 1, or none. Why is this important? Well, this is important because the number of intersections is the number of real solutions to this system. So let's write that down. The number of intersections is the number of real solutions of the system. So in this problem, we would have two real solutions. This one would have one real solution, and then this last one would have no real solutions. So 2, 1, or none, and it's important because the number of intersections is the number of real solutions. All right, let's move on. That's just kind of an intro. Let's go to example 1 here. Now we're going to find how many real solutions will this system have. So learning target, I can find how many solutions there can be for a linear quadratic system. So y equals x squared, that would be our quadratic, and y equals 2x, that would be our linear, and you can tell because x squared is the quadratic. So how many real solutions? So we just said that however many intersections, that's how many solutions. So how do we go about doing this? Well, we're going to put each equation into our graphing calculator or into the Desmos.com website. So your first equation, you're going to type in x squared, and then your next equation will be 2x. And once you graph that, you're going to get something that looks like this. This is a very rough sketch of it. But you would have your parabola, and then your linear. This is not very accurate. This is just a rough sketch, but it's to show you that you have two intersections. So you put your equations into your graphing calculator. Your graphing calculator will give you the perfect graph there. And then you're going to count the number of intersections. So here's one intersection and two intersections. So two intersections means that I have two real solutions. And that would be the answer. So let's sum it up. This system has two intersections. So there are two real solutions. Solutions. Whoa, let me try that again. Solutions, there we go. Okay, so if you were to solve for x, solve the system for x, you would get two real answers, two real solutions. All right, let's move on. And I want you to try one on your own. So now I'm on page 41 where it says try it. So I want you to go ahead and try this on your own. So go ahead and pause the video there. All right, let's see how you did. So what you would do is you would put this in your graphing calculator and you would get something that looks like this. Again, this is just a rough sketch. And you would see that there are no intersections. So what does that mean? If there's no intersections, then this system, if you were to solve it, you would not get any real solutions. You might get an imaginary or a complex solution, but you would not get a real answer. So this system has no real solutions. All right. Let's move on. We're going to skip ahead to page 43 now. Turn the page to page 43. So now we just learned how to find how many solutions, how many real solutions. Now let's actually find those solutions. So one method, we're going to learn two methods, but this first method that we're going to learn today, and we'll learn the next one in the next lesson, but the first method to actually solving for x in these quadratic linear systems is by graphing them. So here's your learning target. I can solve the equation, and again we're talking about the system of a quadratic linear system, by writing a linear quadratic system and solving using the intersection feature of a graphing calculator. So the first thing you need to do is determine what is my quadratic and what is my linear. So remember, the quadratic has the x squared, so I know this is the quadratic, and then this one is the linear. So if I graph this, I'm going to get a parabola. If I graph this, I will get a line. So I just determined quadratic and linear equations. Now I'm going to set each one equal to y, so I can then graph it. So quadratic, y equals 3x squared minus 7x plus 4, and then linear, y equals 9 minus 2x. Now I can solve for x. Now solve for x. Okay. So to solve for x, we're going to put each equation in the graphing calculator. So your first equation, your first y equals is a 3x squared minus 7x plus 4. And then your second would be the 9 minus 2x. So those are in your graphing calculator, and you should have a parabola and a line graphed. Now use that. So I'll give you, if you need a second, pause the video and get that typed into your graphing calculator or into Desmos so you can see it. But once you get that, you're going to look for your intersections. So look to see, where do these two graphs intersect? So drag it over and then find that intersection, and whatever x equals at that intersection, that is your answer. So you should get x equals 2.37. And at the second intersection, you will find that x equals negative 0.703. Make sure you try this on your own so you are grasping this. All right, once you are done with that problem, we're going to go ahead and go on back to page 41. So we just learned a method for solving these, solving for x. Now let's use that knowledge and apply it to a real life situation. So this example 3 here on page 41 is looking at the learning target. I can apply a linear quadratic system to a real life problem. So let's read this real life problem together. It says, Andrew kicks a ball up a hill for his dog, Leica, to chase. The hill is modeled by a line through the origin. So there's our line, that's our hill. The path of the ball is modeled by the quadratic function. So he's kicking the ball and it goes up and down and it makes that parabola there. How far does the ball travel horizontally? How far must Leica run up the hill to catch it? Okay, so we are given two equations. Here is my quadratic equation, and here is my linear equation. So to solve this, we are going to do it just like we did the other problem. So we're going to put these two equations into our graphing calculator so it will graph it for us. And you should get a picture that looks just like this diagram here. So go ahead and do that. Pause the video if you need to. All right, now once you have that graph on your graphing calculator, I want you to find the intersection. So here would be your intersection. So find what that intersection equals there. What does that intersection equal? You should get the point 11 and 5.5. 11, 5.5. So that was step 2. We found the intersection. The intersection is at the point 11, 5.5. Now we need to interpret, what does that mean? What does the x mean? What does the y mean? Well, let's look here. Our x is our horizontal distance, and our y is the height. So at 11 feet and 11 feet horizontally and 5.5 feet high, that is where the path of the ball will intersect the hill. So here's my path of the ball, here's my hill, here's the intersection. So this intersection is at 11 feet horizontally and 5.5 feet high. And that would be your answer there. All right, so that's it. That's all I have for you for your lesson today. So That concludes the video, and you're ready to do your work.